everyone, this is Suresh Kulkarni and you are watching Cosmic Science. In my previous video, we have learned about origin of quantum theory. In that, we have studied limitations of classical theory, which includes Isaac Newton's corpuscular theory and Fresnel's theory and much. We have seen Maxwell's theory as well. Also, we have seen certain phenomena which classical theory couldn't explain, such as X-ray, radioactivity, discovery of electron, which couldn't be explained by classical theory. So, and also it couldn't explain a black body radiation curve and optical spectra. Today we'll see how classical theory failed to explain black body radiation curve. Let's see. Let's see first what is black body radiation, black body, and what is black body radiation. Let's see that first. So, what is black body radiation? Black body is a body which absorbs radiations and re-emits the radiations it had absorbed, or it reflects the incident radiation. So, those bodies are called black body, and the radiations which are emitted by them or the radiations absorbed by them are called black body radiations. So, black body radiation, for example, sun is a black body, and the radiation it emits are called black body radiation. So, let's see how this black body radiation uh, wasn't explained completely by a classical theory. There is a black body radiation curve. There is a black body radiation curve which explains the spectral energy density versus the frequency. What is spectral energy density? I'll explain, and what is frequency of that? I'll be explaining in this video. So let's see what is spectral energy density. So spectral energy density can be further group fragmented to understand by what is spectral energy. Uh, so what is spectral energy? Suppose an atom. This is nucleus. This is an orbit. This is another orbit. So this is an electron here. Electron. When a photon and photon is incident on an electron. Electron jumps from this to this. So when the transition happens, it absorbs a photon. But when electron is again comes back to its original orbit, it emits an photon. It emits a photon. This photon is recorded. This photon emitted by transition of electron is recorded on a film, and this line is called spectral line, and it represents spectral energy which is emitted by transition of electrons. So this is spectral energy, and this is called spectral line. It represents spectral energy. So if there are number of spectral lines, there are different spectral lines of different thickness and intensity, and in per unit length. Number of spectral lines per unit length is called spectral energy density. So hope this is clear. This is a spectral line which is obtained from transition of electrons, and these are the and this spectral line represents spectral energy, and number of spectral lines in a per unit area is called spectral energy density. So how on what factor does spectral energy density depend on? So it depends on frequency and temperature. Uh, Frequency and temperature. What is this frequency and what is this temperature? Suppose a black body looks like this. This is a black body and this is a cavity. In this cavity there is a black body and this is a incident radiation. So what happens when radiation is absorbed and re-emitted by this black body? They move in this direction, or they may move in this direction, may move in this direction or in this direction. They can be emitted in any direction. So what is the frequency per second? How many radiations are emitted in this cavity in a unit time are called frequency, and the temperature of this cavity is called frequency of this frequency of this black body, and temperature of this cavity is considered. So this is a diagram how a black body in a cavity is placed and radiations are emitted inside of cavity. So let's see, some scientists tried to give the expression for this frequency as well as spectral energy density. They tried to give a expression for spectral energy density and as well as frequency. Let's see who There was a scientist when he tried to explain the black body radiation curve with the help of plotting a graph of spectral energy density versus frequency, and his expression was true for higher high, true with the experiment for higher frequencies. Uh, it failed for lower frequencies. Similarly, some other scientists like Relay and James. Relay and James, they considered they treated radiations inside a black body as a standing electromagnetic wave. Uh, so suppose this is a black body. So suppose this is a black body. They considered there are no reflection of or emission of electromagnetic waves. They considered it as standing electromagnetic wave. So, so what they found out that they found out that they estimated the spectral energy density as well as uh, in the range of frequency V plus VdV. They evaluated them. They find the product of spectral energy density versus product of average of energy of the oscillator. Oscillator in the sense, if this is a emission of radiation in per unit volume. Per unit volume, what are the modes of vibrations, and what is their frequency? Modes means, is it towards the black body or it is away from the black body. So it is considered in this region, and they found out that their expression was compared to the experimental results. They found that the expression was holding good for lower frequencies. Thus, classical physics, that is classical physics, failed to explain black body radiation curve, and there was no single expression that could explain the experimental black body radiation. This attempt was done by this was explained further by quantum mechanics. I'll be coming on to that. This was about black body radiation curve. If you have understood it, you have doubts, comment down below, and please do like, share, and subscribe for some such interesting topics in my coming videos. With this, we'll uh, we'll I'll take your leave, or we'll stop till today. We'll see you in the next video. Thank you.